Yo, what's up guys? So I've made a little progress on my game right here. So as you can see, I've not expanded the memory yet. I just wanted to see what I can make with the memory I have currently. So I have a program in here, and I'll show you. It's this back one right here. It's very large. It uses up every single memory slot or instruction memory slot. And all it does is it takes a dot on the screen and moves it up and down. So it's a really fairly simple program. It uses two if statements, obviously. So I give it an input, and then it basically checks if an input's equal to this number, it does this, and if it's not equal to that, it goes on to the next if statement, and if it's equal to that, it does this, and if not, it skips the next if statement. I only have two if statements, so we'll just skip to the end. So right now I'm just inputting it manually, but normally I would have, or I guess when I finish the game, I'll have like buttons basically that are kind of like encoders. So they will output a certain combination, certain digit, and that will move the dot in a certain way. But let's test it out. So right now what's happening is I'm gonna turn everything up to 20 times speed. And there we go. So the dot reset. So it was really simple. So what it does is I have a 1. I input a 1 if I want to go up, and I input a 2 if I want to go down. So that's easy. This 1 also acts as the number that I add and subtract. So I can only add or subtract 2 memory slots. So I can't like subtract a 1 from a memory slot. I would need to load a 1 into another memory slot, then subtract it. So this one kind of plays two roles. One, it identifies, like it's, if it's a 1 in later if statements, it moves it up. But it also acts as adding or subtracting to move the dot up or down 1. And as you can see, it's not just one dot, it's actually a 2x2. I'll explain the pixel display in a sec, but it's 2x2 pixels. So then we have 3 and 4. So this one's the x coordinate, this one's the y coordinate. I just try to put it in the middle of the screen. It's an 8x8 display, so I just gave it the coordinates 3, 4. Then we have these two here that displays the x, displays the y, and I'll show how it memorizes those in a sec. And then what it does is it goes to my input, so it takes an input and memorizes it. And then here we have an if statement, so it checks if the input is equal to, in this case, memory slot 1, which is just the 1. If it checks, so if it's not, it skips to the next if statement over here. But if it does, it really just adds 1 to the memory, and then it jumps to the end basically. So it just adds, I guess it adds 1 to the coordinate, and saves it to a different slot, and then it jumps to the end. I'll show you what happens at the end. Then this is the next if statement, and it checks if the input's equal to slot 2, which is just a 2. It checks. If it's not, it goes to the end. And then in this case, it subtracts because we're moving down, so it subtracts 1 from the coordinate. Now at the very end here, we have our move function, so we basically replace our old y coordinate with our new y coordinate, and then we jump back to the beginning. So it's basically a loop, so I can do this as much as I want. So let's put in a 1, and as you can see, the dot will go up. It's there we go. So I can keep doing this over and over again. It's very slow. Again, this is at 20 times speed. But I guess I could probably make this. I'm going down now because I put it to 2. Give it a sec. Takes a little longer with the subtraction. But okay, go down. Yeah, so I can only move it up and down. So this is really only half of the game. So I will have to basically double my memory slot. I did the calculations. I think I'll need 28 memory slots to fully run the game. Sorry, instructional memory slots. This only uses up, I think, 8. No, sorry, it only uses 7 actual RAM memory slots. So I'm fine on here. I have 16, but it needs more instructional memory, and I don't really have a better method of storing instructional memory, so I'll really just have to expand it this way. I might need to find a more efficient memory structure, but for now, this is what it's gonna look like. But that's fine. Now this screen over here, I'll explain how the screen works. All this white, I guess, is just white wool is the screen. I literally have it I just took it out of the display. And for the display, I actually added one more thing here. So down here, this is my display line. So whenever the display function is called, it sends a signal through here, and that's what unlocks these comparators, and then that outputs the number. So what I did was I also took that signal and turned it into its own line so that it can actually recognize when the display is called. Because I was originally thinking, I'm like, okay, I can just have all the digits like combining into one line, and there has to be a 1 in there, right, at some point. So it will send out a 1. Whenever it sends out a 1, it will close it or whatever, or memorize it. And then I realized, what if I want to just input a 0? Like, what if the coordinate is 0? And that would not, because it would not, there's no signals there, it would just output 0, 0, 0, right? So it would not recognize that. So I decided, okay, well, I'm just going to have another line for the display that can then memorize it. Now, this is a it's a very simple shift function. So we have a 2-tick pulse extender, I guess, or pulse shortener. I don't really know what you would call this, but it only sends power to the torch for, I guess, 1 tick technically. So it unlocks the repeater and allows the signal to travel around. So it unlocks it. So I'll show you right here. If I were to send a signal through, so that happens really quickly because I have it turned on 20 times speed, or tick rates up 20 times. But as you can see, now this repeater's on, this repeater's off, and we can do that again. There we go. So how this works is whenever the repeater is on here, it sends another pulse that unlocks this briefly and then locks it again. So that's really just a tiny memory unit and just has 2. So this is the X memory unit, this is the Y memory unit, and this is the coordinates, I guess. And it's really simple. They just go into some decoders, and it's just a grid right here. So there's always going to be 1 torch on. So every single torch is powered by 1 redstone or row, I guess, and 1 redstone column. And so whenever you put in a coordinate, because it's a decoder, it'll have 1 line, so only 1 column and 1 row will be unlocked, and that will only turn 1 torch on. So it's basically just a coordinate system. And then I have this into a screen, so it has a memory. You can clear the memory. This is not my design. I think this is also Mattbatwings, because I talked about that last video. As you can see right now, this is on because it's what I also have this hooked up to is this will also automatically clear and display, so basically automatically switches frames, so whenever it gets a new X and Y coordinate, it will switch. So right now it's here, but whenever we reset the program, it'll go back to the middle. So it's really simple. It's just whenever you can allow a signal through with this, it memorizes it, and then you can clear a signal with this line right here. So it's just really simple memory units. So yeah, so making use of the grid coordinate system and the screen, I can input 2 numbers and it will turn them into coordinates and display them. And so that's my plan to make the dot move around. So I'll just need to have 2 more if statements to move the X and Y. So this is just a demo of my prototype. I'll be expanding the memory. I'll just have to connect up these 8 digits here to this yellow step counter instead of these 4 digits down here, just to give it more memory space. So technically I could have 256 memory slots, but I'm only gonna give it like 32 because that's all I need for the game. So I'll be continuing to work on that, just expanding the memory, making the counter a little larger, and programming it to finally finish the dot game. So I'll probably do that next video, but for now that's about it. Peace.